Okay, so this is a quick video on some instruction on inverse trigonometric functions. In fact, we're going to look specifically at composition of inverse trig functions and regular trig functions, and also finding exact value. We're going to look at an example that specifically does not have an angle that we're used to looking at on the unit circle. So this is a little bit more difficult in that sense. So the example that I'm going to write about is the inverse sine of the sine of negative 59/65 pi. Okay, cool. So first thing you want to do is take a look at that angle. So where is that angle located? Negative 59/65. So you have a negative rotation, 59/65. So if it was 65/65, 65/65 pi, put that in there, 65/65 pi, that's equal to pi, of course, because this is just 1. So negative 59/65, that takes us to an angle that terminates somewhere here in quadrant 3. So we don't know what the sine of this angle is, because in terms of an exact value, because we haven't dealt with any angles like that, and that's not really important to figure out the answer to this problem anyway, but knowing that it terminates in quadrant 3 is important to us. So let's think here for a second. The sine of an angle is negative if the angle terminates in quadrant 3. The sine of the angle is negative if theta terminates in quadrant 4 as well, and the sine of the angle is positive if the angle terminates in quadrants 1 and 2. So depending on if this is a sine function or a cosine function, you're going to have to figure out whether the value of this, the sine of your angle, whether that's positive or negative. That's going to depend on whether it's sine, cosine, or tangent, and what quadrant the angle terminates in. Okay, so we know that it's negative. Now the next thing to determine is, what is that? That's the reference angle. So specifically, what is it going to be? So we'll call this alpha, say. Well, in this case, we are exactly 6/65 pi away from the x-axis. So if you rotate negative 59/65, if you rotate negative 59/65 pi, if you rotate another 6/65 pi, you would arrive at the x-axis. So that means this is our reference angle. Okay. So how does that help us? Well, we're trying to find the sine inverse, the arcsine, of whatever this ratio comes out to be. Well, we don't really care about that ratio, except for that ratio is negative. Okay. So we're going to go back here. Since the sine of the angle is negative, taking a look, the arcsine of, and I think in class I pointed out we could call this, if you want to give it a value, we could call it Q or something, some ratio. The arcsine, or the inverse sine of Q, what do we know about Q? We know Q is negative. So the arcsine of a negative value will itself have to be negative. And in fact, it's going to be the angle that is the reference angle here. Negative 6 65th pi. Negative because we're talking about a ratio whose value is negative. Let's bring this to look a little bit full circle, no pun intended, to a sketch of inverse trig function. In fact, inverse sine function. This has a domain of -1 to 1 because our inputs of arcsine, the input to this function is a ratio between -1 and 1, including -1 and 1. The output has to be from -pi/2 to pi/2. This is just for arcsine. If your problem is arc cosine or arc tangent, you're going to have a different problem, but the process is going to be similar. So in this case, we don't know where Q is, but we do know that Q is negative, so Q probably lies, who knows, somewhere right here. This might be Q. And this angle is -6/65 pi. All right, and that becomes the answer to our problem. This is equal to -6/65 pi.